Hi, everyone. So my name is Matthew Rathbone, and I'm here from Foursquare. I'm here to talk to you about building and improving products with Hadoop. So just before I get started, just to give you a little bit of context about Foursquare, this will be the extent of my product pitch, I promise. Foursquare is, for those who don't know, is a kind of a social network and place discovery app. We allow you to see where your friends are, share your location with friends, but also kind of find new places and find cool places to go. So just a few stats for the amount of data we have. The check-in was, for a long time, our primary kind of data commodity. We have over 4 billion of those in the system, so you check in when you go to a place. We have 35 million users, over 50 million points of interest. We only have 150 employees, but we process over a terabyte a day. Less than that compressed, but I wanted to make it a little bigger. So before I get started in my talk, I want to kind of have a bit of a story to kind of illustrate what I'm trying to get at with what I'm saying today. So a few years ago, I used to live in London, and like most people who live in London, I had a good friend who worked in finance. And he worked for an asset management firm that kind of handles the investments for large, long-term investment companies like pension funds. And he was telling me one week about this big system they'd spent a lot of time building. They'd poured 2 years of time into building this grand user interface, web-based, all their fund managers could access it. They kind of aggregated all the data, handled all these different product types. And you know, like nobody really liked it. Like the fund managers didn't want to use it. They wanted something simpler, something more like a spreadsheet. And this kind of carried on for a long time. And I saw my friend again a few months later. And it turns out that what they ended up doing was canceling the project almost entirely and instead spending about 3 or 4 weeks building some Excel macros so that everybody could manage their funds in Excel. And the moral of this story is not that you shouldn't try and build a big piece of software, but rather kind of using the right tool for the job, even if you don't feel familiar with it, or it seems like the wrong thing to do. If they'd done a bit of exploration or even just asked a question of what these guys wanted, they would have seen that the right tool for the job in this case was Excel. So that's kind of the whole thesis of my presentation, is using the right tool for the job. And as an engineer, I feel like we already do this pretty well in a lot of different ways. So we use Nginx to serve static files. It's really good for serving static files. It's really fast. We use Perl if we want to write some regular expressions and chomp through a bunch of data and see what it can extract from us. We'll use XML if we want to like confuse people, and because that's kind of the best use for it. And similarly, Hadoop is really good at counting. And I feel like we've already kind of taken advantage of this in analytics, because really, like the primary thing you're doing in analytics is counting things by minute, by tenure, by user retention, all these different things. But my kind of idea is we should also be using it to count things for production. So counting, it seems pretty simple, but there's kind of a lot of good use cases. And I have a couple of examples from around the web. And I'm not saying that these examples actually use Hadoop, but I think they fit really well in the Hadoop use case. And I'll kind of explain myself as I go. So on Amazon.com, there's always a section of new for you, recommended for you, things that you'll like based on your previous browsing history or purchase history. These are kind of just item-to-item counts. So people who buy some TV show tend to also buy these other TV shows. So kind of custom newsletters. People who follow these users might also follow these users, might also be interested in these tweets. Again, you're just kind of, the keys are 2 users or 2 tweets, and the counts are just kind of the number of people who've done those things. In the non-tech world, something like a coupon redemption system, you're giving people offers based on their previous purchase history. So if you tend to buy a lot of candy, then it might recommend you also buy some soda, because those two things go hand in hand, and it might give you some sort of discount on Pepsi products. Again, I have no idea whether these companies use Hadoop, but these types of things are pretty easy to kind of migrate to this offline system. It doesn't require like immediate response times. You don't immediately need a coupon for something when you're in the store. They can kind of compute it overnight. So from Foursquare, I have a couple of examples. So I don't know if this is legible from the audience, but the 2 sections on the right-hand side are more places like this place, and places people tend to go after they go here. So in this case, it's a coffee shop, so other similar places are other coffee shops in the area. And after going to this coffee shop, people tend to go to shopping or Dean and DeLuca. Again, this is kind of very simple counting, aggregating on 2 keys. We also do some kind of other stuff, like we don't always have the opening times for a venue, so we kind of guess. Based on when people go to a venue, we count the hours during each particular day of the week that people go, and we have some sort of cutoff, and we say, well, it's probably open at these times, and we just give you the hours it's busy. So you can have a reasonable confidence that if you go to this coffee house between one of these times, there's going to be some people there and it's going to be open. The last example is what I'm going to use for kind of a use case for building this kind of production pipeline. And we call it statistically improbable phrases, but we present it on the website as things that people talk about. And what this really is the data for the venue, so tips people have left. We extract things that are unique to that venue and not unique to other venues. So at this coffee place, people talk about the iced coffee and the espresso. They seem pretty obvious. But these have a lot of use cases, and they can be really powerful. So we can use these statistically improbable phrases to do a bunch of things, like menu extraction, sentiment analysis, whether people like the venue ratings, generally what do people think about a venue, specific recommendations. So if you like places that are good at espresso, then you might want to go somewhere else that has a lot of espresso. Search indexing, pricing data, all sorts of information we can extract if we can identify these significant phrases at each venue. And the way we build this is just basically a lot of counting. And what I mean by that is we use a fairly standard algorithm, which is the term frequency inverse document frequency algorithm, where you count the amount of times a phrase appears in a particular venue. And you compare it to the amount of times that phrase appears globally in your whole data set. And combined with a bunch of other kind of filtering and ranking, like language filters, you can get this kind of pretty good sense of what phrases represent a venue well. So our pipeline for this is we start with a language model, so we can tokenize our data. We run through this algorithm, and then we can recompute this and deploy it nightly. So why use Hadoop for this? Why use something like Hadoop for this? There are many other ways you can do it. Some potential problems we've run into problems like this with other data sets. So without Hadoop, say you do this online or in some sort of other offline system like a queue worker, some of the problems you can have, you might need to query throttle requests against your database. For every venue, you have to read all this context information, all the tips, all the likes people have had, everything they've said about a venue, and then write a bunch of data back to the database. You might run into problems, and you might kind of like do a denial of service attack on your database cluster, which isn't really a good idea. Other issues which are not so obvious, venues might become out of sync. If you're processing venues one by one, and you've found a bug in the system and you need to roll out a big change, and you're processing things one at a time, you could have kind of an inconsistent state where you have 1, 2, or maybe 3 versions of these phrases deployed to all other venues. Everything that inherits from these phrases is then going to suffer because everything's going to be inconsistent. Other problems like how do you store debug data? Are you writing more data to the database so you can read things out afterwards? And what about other similar workflows? Do you have basically an entire other worker also reading from production to do similar things? So some of the benefits we found with Hadoop, and I'm going to talk a little bit about the infrastructure you need to support this, is really Hadoop, contrary to what a lot of people, I think about Hadoop, is it allows us to do quicker deployments. It allows us to kind of have modular and reusable code, because by definition, each Mapreduce task is its own kind of modular own kind of entity with its own inputs and its own outputs, and you can use it as such. It allows an arbitrarily complex combination of data sets, so you don't have to hit your production database. You can have all this offline data to use. And every step of the workflow creates value. If one step creates a language model, that language model can be used elsewhere. If the next step computes global phrases and global phrase counts, those global phrase counts can be used elsewhere. So just some examples of what I mean by this. we had an issue with our search index, which is generated through a similar process, where if you searched for a haircut in San Francisco, it'd tell you to go to the Apple store. And that's because a user said, hey, Apple, how about less shiny pizzazz and fancy haircuts and more fixing by MacBook? All right, so this is a clear issue. Like, there's one tip that mentions haircuts. We probably shouldn't tell you to go to the Apple store because one guy says haircut in his tip. So we kind of need to redeploy a fix for this and kind of have a better ranking. So data and modularity, so reusing the outputs from all these components and using a lot of data. This is our pipeline for the statistically improbable phrases. We use 5 different data sources, and we output 1, 2, 3, 4 or 5 different output data sets to use in production. So each of these different stages along the way can contribute to like our production website and give us some debug data and allow us to kind of split things up and test them independently. So here's some kind of debug examples. And what I kind of want to say about this in a minute is the fact that we're able to create all these outputs is kind of dependent on an infrastructure component I'll describe later. But once you've solved it once, you've kind of solved it for every time you need it. So it enables to do things like this, right? So we have, this is kind of information from our language model. So I live in Wisconsin. So in Wisconsin, they talk a lot about cheese curds, which are delicious. And cheese curds appear in like 1,118 unique venues. This is how many users have said the word cheese curds. There's 1,300 menu items that mention cheese curds, etc. So if we see a problem with some data that we've extracted, we can kind of go into this debug data set and take a look at it. So secondly, we have this kind of sentiment data set. So here are a bunch of tips from a place in Madison, Wisconsin called the Great Dane. And you'll see cheese curds mentioned, I think, at the top. So this is kind of a sentiment of each tip, or what we think is a sentiment of each tip. I don't know why that's switched. So we can kind of go into here and then drill down. If we click on the probability, we can see, based on our language model, which words in each of these tips contributes to the score of being a positive sentiment. Okay, so in this case, we have the word must followed by, preceded by you. So it's like if it contains you must, that has a positive sentiment. But equally, must get has a slightly negative sentiment. So all these things in combination create this kind of aggregate sentiment score. So as I kind of alluded to, this pipeline requires you have certain pieces of infrastructure in place. So I just want to kind of touch on a little bit about this and kind of what these infrastructure components are and how they enable us to get all the benefits of Hadoop that we need. So the 3 infrastructure components that I think are pretty key to our pipeline and being able to use it for production is really 3 things. A scheduling and a dependency management system. So the language model that we build in Hadoop requires our database dumps to be there on time. And once that language model is finished, then other jobs can run like sentiment analysis and the n-gram counter and global aggregation. That also requires us to have data in the first place. So we need to have some method of getting log data and production database data into HDFS. And thirdly, we need somewhere to put the data afterwards, right? Some sort of key value store, something that's MapReduce friendly. Because again, you don't want to be doing a bunch of inserts into MySQL and be forced to go through the process of throttling it. Especially, we have 50 million venues. If we're computing data sets for every 50 million venues, and we're computing 5 or 6 data sets, that's a lot of inserts we have to do every night, right? So you need something that's kind of friendly to MapReduce. So some general options. So you don't have to build all this yourself. A lot of these have been talked about already in the conference. So for dependency management, you could use Uzi if you really like XML. You could use Azkaban if you don't like XML. We use a system called Luigi, which is more a dependency management system than a scheduling system. We really like it. There's a couple of other options. So this is, I don't know if you can see the edges in this graph, but this is kind of one of our dependency graphs. So each of the colored squares is a MapReduce job, and each of the lines or the edges is a dependency between jobs. So we have like thousands of jobs that run nightly. Green jobs are completed, blue jobs are running, orange jobs can't run quite yet. So this is kind of what's important about the dependency management system. It allows you to kind of manage this wholesale. If you have to do this for 3,000 things in an ad hoc way each time, it's kind of a disaster. So database and log ingestion. You need to get database data into HDFS somehow, or we do at least, and it really helps to get log data there. So again, a bunch of these technologies have been talked about. Scoop and Mongo Hadoop for bringing data from databases, and Kafka, Flume, Scribe, et cetera, for bringing log data. We use Kafka, but it largely just depends on taste. I don't know if I mentioned this, but we create a separate backup of every one of our databases every single night. So we don't do incremental dumps, we dump the whole thing every night. This way, every job has a really consistent and generally reliable view of the data every single night it has to run, and we don't have to worry about inconsistencies if we've modified records from one day to the next. And finally, you need a Mapreduce-friendly data store. So a few obvious ones are H-based, Cassandra, and Voldemort. We actually built our own Mapreduce-friendly database, which essentially just swaps in a file that it reads from. It's a key-value store. It's read-only. You have 5 reducers. You output 5 files. You have 5 servers serving them. And that's very similar to Voldemort in the open source world. So just kind of an illustration. So we have a bunch of MapReducers. They create a new version of a check-ins data set in this example. There are 3 shards. We then ping Zookeeper and say, oh, hey, this is new version of the check-ins data set available. Maybe someone wants to know about this. And our data store goes, oh, yeah, that's pretty interesting. Why don't I load that up, and I'll start paging that into memory instead of the old data set. So it just kind of swaps in naturally. And that's really easy because you're not doing inserts. It's just literally swapping the file it's based on. You don't have any issues with kind of taking the database down. We just take one shard down at a time and reset it. So that's great, right? Like, it's great for us. We already have these infrastructure components in place. But if you don't have these infrastructure components in place, and we didn't, how do you get started using it in production? And there are different use cases using this stuff in production than using it in analytics, right? You really need everything to happen overnight reliably, and you need to have somewhere to put the data that's really low latency. So if you don't have these components, the best way to start using Hadoop is to not use Hadoop at all. And this may sound counterintuitive, but you just kind of, if you pretend that you are using Hadoop and just kind of use everything in batch, that's kind of a really easy way to get started without having to worry about getting a lot of infrastructure. There are other reasons to not use Hadoop for version 1 as well. For example, your idea might be terrible, right? You might have this really good intuition about how you can improve your data, and it could just turn out to be absolute bunk. And if you've gone through the process of writing a giant MapReduce job and a pipeline, and you've got all this infrastructure in place, and you're ready to go, and then you finally get the data and it's kind of crappy, then you're stuck, right? You don't have enough infrastructure yet, like I said, so just build it when you need it. And version 1 might not be very complex. So version 1 of our statistically improbable phrases was a lot simpler. In fact, it was a spreadsheet. So here's an example of something we did which didn't turn out very well. So this is kind of to hopefully drive home my point that you don't need to do it in Hadoop. This is a project where we thought it'd be pretty neat if we could compute the similarity between neighborhoods and cities. So, I don't know, like the East Village in New York might be similar to a certain neighborhood in San Jose, or a certain neighborhood in London, or a certain neighborhood in San Francisco. So we wanted to kind of build that matrix. And so if you're in a new city, we can say, oh, hey, you hang out in the East Village, you should probably go to the Mission in San Francisco, as an example. So we built this matrix. This is just New York neighborhoods, and got these kind of similarity measures. And we compared each neighborhood side by side. And it looks pretty cool, but honestly, it was like totally useless. Because there's really just too many factors influencing what a neighborhood looks like. Like Soho has a lot of offices, but if you ask people in Soho, they're not going to talk about it being like a big corporate center. Places with train stations were particularly troublesome. So Midtown would always get compared to like some really crazy areas all over the country because of where the train stations were. And it really wasn't anything to do with the train stations. And while this stuff could have been optimized, there really wasn't enough like interesting things for us to look at in the data set. So with SIPs, we went through a similar process. So this was all computed with a Python script that we just kind of downloaded a chunk of data for New York and ran it and saw what it looked like. And it took a day, and it wasn't so bad. So version 1 of statistically improbable phrases was pretty similar. We got an off-the-shelf language model. we took a subset of our venues and tips, mostly centered around New York employees' data. So we were all familiar with the data set. And we could all read the data set and understand where things had come and where everything would come from and how it had been generated. Again, we didn't use Mapreduce. We just used a simple Python script to do this, which ran in a couple of minutes. And we didn't push to production. We just pushed to a spreadsheet. And this kind of enabled us to take a look at the spreadsheet, get a bunch of people to look at it, see if it makes any sense. If it does make sense, we can go ahead. And it looked pretty good. So version 2, we started building our own language model, which is based on all our data. So people use words in like tweets and in Foursquare tips that they wouldn't necessarily use if they were writing a book. So building our own language model really allows us to tailor it to our data set and make it a lot more accurate. We can also filter out other languages or do any kind of like word ranking changes that we need to. So this was rewritten as a Mapreduce, but we manually loaded the data to production. So of the infrastructure components I talked about, this requires one of those 3 components, and that is the data sets to be there in the first place. So this required us to have our database data dumped in HDFS so we could run this once a week or whenever it was that somebody got around to running it. And loading it into production, we would just sit there and wait for it to do inserts into our production database and make sure that we didn't take anything down. And at this point, we're in a pretty good position. The data's in production. We can iterate and improve and keep it moving along and improve it as we go and make sure that it is valuable. So then version 3, we were like, okay, this is going pretty well. So let's incorporate some more data sources. Let's just not take tips. Let's take likes and shouts that people have said and other kind of maybe some third-party data. And we want to deploy this automatically to a key value store. So we'll build out that component. And at this point, we had the data store running, so we also had access to all this debug data so we could see when things went wrong. And at this point, we're in a perfect place to iterate and improve. We can run this pipeline every night. We can deploy it every night. And when we see bugs and errors, like the error I showed you earlier with the Apple Store, we can easily just swap in the whole data set for the next day, and everything is fixed. We don't have to worry about iterative improvement, and we can feed this pipeline to other things too. So what really enables us to do this culturally is kind of this ability to explore new ideas without kind of being mandated to turn them into a production data set straight away. So it's pretty important that our data scientists and our engineers have the ability to explore these data sets in a kind of hacky, ad hoc way, to find out whether things are useful or interesting, and apply those in ways that they see fit, and not just go straight into the Mapreduce and the implementation, being able to iterate and do this quickly. So in summary, to kind of go back to the story I was talking about before, for us, Hadoop has been the right tool for building these data sets, and we have many tens of these data sets in production right now, feeding everything from like recommendations to all this kind of secondary information, like where people have been, what times places are open. We're using it to extract really interesting data, like whether someone has a patio, without actually them telling us that they have a patio, and being able to identify good photos for venues so that they can have a really, really nice experience when you go on the Foursquare app. Having all these infrastructure components in place really lets us kind of do anything we want with this data. That's kind of all I have. I'm happy to take any questions. One final note is you guys should all check out Hadoop Weekly if you want to keep up on Hadoop news. It's pretty good. It's run by my colleague, Joe Krobak, who's talking later. So thank you very much. Does anybody have any questions? If so, can you please use the microphones? Okay, so the question was, going from version 1 to version 3, what was the time frame involved in that, and how many people were involved in it? Is that the question? Yeah. I think version 1 was done kind of as just some side project by one of our engineers. So from version 1 to version 2 was probably like a month, a couple of months. And then version 2 to version 3 was probably like another month or two as well. So maybe 3 months. But that wasn't really due to any kind of plan. It was just kind of when we got the different infrastructure components in place and how fundamental it became to the experience and how useful we thought it was. I think it was kind of one person working on it most of the time. Okay, there's no other questions. Thank you very much.